Hi, Vicki Williams here. Today I'm going to be doing for you properties of solution, electrolytes, and non-electrolytes. And so the way we're going to do this, we've got a whole bunch of little beakers that we're going to put different solutions in. And we're going to use a conductivity probe. This is it right here. The first step is to wash it off really good, so I'm washing it with distilled water. Except this water bottle, of course, does not want to work, just because I'm on film. Okay, and we're going to be reading the conductivity in units of microsiemens per centimeter. And I'm going to show you the conductivity, and I'll let you write down the numbers. So all I'm going to be doing is putting the solution into a beaker, swirling around the conductivity probe, and then when the reading stabilizes, you're going to write down that reading. And I'll tell you what each chemical is as I go along. Our first chemical is calcium chloride. I'm going to find my little beaker that says calcium chloride and put it in. I'm going to put the conductivity probe in and swirl it around, and we'll wait for the conductivity to kind of settle down. Okay, I think we can call that done. 10,788, 8790. Okay. In between each solution, I'm going to rinse the conductivity probe. Our next solution that we're going to test is aluminum chloride. I've already rinsed the probe. Now I'm going to stir it around a little bit and then hold it still, and we'll get a reading. The next chemical we're going to test is sodium chloride. Now, while I'm testing sodium chloride, let me tell you a little bit about electrolytes. Electrolytes are substances that break up into ions in water, and because they're ions, and remember that ions are charged particles dissolved in water conduct electricity, and that's what we're measuring here. And compounds that don't break up into ions will not conduct electricity. That's the end of our solution A test, and now we're going to move on to solution B. Solution B are going to be acids. Now, some of them are going to be strong acids, Some of them are going to be weak acids, and one of them might not be an acid at all. It's an acid on paper, but it may not conduct any electricity. So let's see how these guys test. The first of the acids we're going to test is acetic acid. Now the difference between a strong and a weak acid is that strong acids dissociate completely. In other words, they completely break up into ions when they're placed in water. And a weak acid does not dissociate completely. In fact, it dissociates very little, and you would expect it to have a very small value. And for acetic acid, it looks like we've got right around 1420. So that, not 1420, I'm sorry. Looks like it's around 410. So that looks like to me that it would be a weak acid. Now we're going to be testing hydrochloric acid, which is HCl. Let's see if this looks like a weak or a strong acid. Okay, very different from the acetic acid. Very different values. So do you think hydrochloric acid is a strong acid, or was acetic acid a strong acid? And what you're going by is how well it conducts electricity. The larger the number, the better it conducts electricity. Now we're going to test phosphoric acid, H3PO4. Now this subscript 3 behind the H means that it could potentially produce 3 hydrogen ions in solution. But let's see how strong or weak of a reading we get from phosphoric acid. The next thing we're going to test is a chemical named boric acid. Now it has a 3 after the H. But as I told you, there would be probably one that would look like an acid on paper, but maybe it doesn't conduct electricity much at all. So let's see what boric acid shows. It's staying right there at 99.